pranešėjas, kuris prisijungė iš Jungtinių Amerikos valstijų. Tai yra Rodale Instituto mokslinis darbuotojas Drew Smith. Ir jisai mums papasakos apie ryšį tarp sveiko dirvožemio ir žmogaus sveikatos. Dėmesio į ekraną ir, aišku, galėsite girdėti vertimą pas ausinėmis.
Thank you for inviting me. It's a real honor and pleasure to be here in our work and our work to connect soil health and human health. When our founder, J.I. Rodale, started Rodale Institute, he wasn't a farmer, and he was trying to understand how agriculture and farming connected to human health. He started Organic Gardening and Farming magazine in 1942. In 1947, very much after the Soil Association was formed in England, he created what was now the Rodale Institute, but at the time he called it the Soil and Health Association. He started that, he said, healthy soil equals healthy food equals healthy people. And he was really trying to say we should start to explore this connection between how we grow our food and human health. It was becoming evident in the 1940s that people were not very healthy, especially in the United States and in England, where he was interacting with people, and was trying to understand why this might be, and was there a connection to our food and our food system. So I want to take a quick snapshot of the United States today. In the United States, really more than 50% of the population has some chronic disease. We're one of the maybe the most wealthiest countries in the world, but we're one of the sickest countries in the world. And why is that? And it looks like the cost of our health care is astronomical. This is the expected cost just to treat chronic diseases that are really preventable over the next 25 years. And it could be much greater than, this crisis is maybe greater than our military campaigns, but we don't seem to have the same urgency on to fix this problem. This map shows the use or the overuse of nitrogen in the United States. And what we're finding is that this massive amount of nitrogen in the major crop production areas in the United States is leading to contamination of wells, groundwater, that are resulting in ailments or sickness that had not been seen before in a very long time. It's leading to contamination of lakes and streams and estuaries that are resulting in really our inability to produce food from fisheries. Since the beginning of genetically modified crops, so genetically modified or herbicide tolerant crops came into the United States, started being used in 1996. So then we now have a massive amount of herbicides, not just glyphosate, the active ingredient in Roundup, to the point where 70% of all water samples that were collected in the United States in a study had some form of glyphosate. That included rain, like rain that comes down from the sky. And 80% of all Americans, when tested, have glyphosate in their body. And we are using now more toxic chemicals and herbicides because the glyphosate or the herbicides we're using are no longer working. The weeds are resistant, and so we're using more chemicals and we're using more toxic chemicals to control weeds in our major crop production areas. And that is leading to, and this is a very new study, this is leading to cancer rates that are as high as cancer rates from smoking. So no one would dispute that smoking cigarettes, especially smoking over a long period of a lifetime, is unhealthy and could lead to cancer. But there is many who dispute that our use of chemicals in the environment or for agriculture are leading to sickness such as cancers. But really the evidence looks undisputable. And so I say this because as I move to discuss more about soil and the links between soil and nutrient quality, I just want to make it clear that organic agriculture, or choosing organic agriculture, is still one of the most healthiest things that we can do to improve the soil, to improve the environment, but to improve human health. So one of the reasons we really started to think about this was several studies that came out around 2000 that all demonstrated a nutritional decline in our food. And if you look at this, you see that we have many of the major nutrients had significant declines in our major food crops. These are vegetables and grains. And at the same time, starch and carbohydrates increased. And when we look around, especially the United States, we have an obesity epidemic where people are eating and they have too many calories. And this is leading to something that we call hidden hunger, or where people get sufficient amount of calories, but they're deficient in major nutrients that are needed to support human health. And this includes not just proteins, but essential amino acids. And so for this reason, we started an exploration. And one thing we do know, when we look at the literature, we look at research, is that part of this decline in nutritional quality is due to crop breeding. So in this graph, I'm showing you an example in the broad-bulk wheat trial at Rothamsted Research in the UK. That is maybe the longest running research trial in the world. And in their wheat studies, if you look at this graph, you see really no difference in yields and in the nutritional quality of the nutrients they were testing. But in 1960, they switched varieties from their traditional wheat to the new semi-dwarf wheat. This is kind of the start of the Green Revolution, where Norman Borlaug had bred wheat to be more productive and smaller. But as we looked at this over time, we started to see that it resulted in higher yields. If you look at the top graph, you see the yields increased. So this helped with hunger. But you see that there's a decrease in many of the major nutrients: zinc, iron, copper, and magnesium. So we know that it's a result of our crop breeding and mostly a single focus on improving crop yields. But what about the degradation of our soil? If we look at reports over the same period of time, here's several from the UN. Really, since the beginning of what we would call industrial agriculture, we continue to see soil degradation. And we started to ask the question, well, is there a connection between the degradation of our soil and the nutritional quality of the food that we're eating and ultimately human health? And so this is our question, because everywhere we looked, we saw organic farming improve soil. We have our own long-term studies that I'm going to talk to you about. And we also have other studies around the world that every time we start to implement organic farming, we improve soil health. So could this be a solution to improve nutritional quality of our crops and ultimately improve human health? This study I thought was one of the most well-done studies because it pulled together a lot of different research that compared organic and conventionally grown crops. And this was done in 2014. And here are some of the results. It is no surprise that conventional crops had 4 times the amount of pesticide residue. We find higher cadmium levels in conventional crops. This is mostly due to phosphorus fertilizer. And we see nitrate and nitrate levels that are higher, mostly because of synthetic nitrogen fertilizers. The organic cereals, though, had lower protein and amino acid. And this, again, is probably due to the fact that organic farms or organic farming tends to be lower in nitrogen availability or use in nitrogen. But what we see that's very clear is organic crops have higher antioxidant activities, or they have higher levels of what we call phytonutrients or bioactive compounds that are critically important for human health and are a current active area of research in the medical community. So we first thought, well, could we take a look using our farming systems trial? The farming systems trial started in 1981. So we are in year 44 of the farming systems trial. And the farming systems trial was designed to be a side-by-side comparison of organic systems and the standard conventional system. The 2 organic systems, we call it, the first one, organic manure. And this system replicates or mimics a farm that has livestock, maybe a dairy or beef operation, and therefore they have manure that they can recycle back, and we recycle composted manure back every 4 years to the fields. And it's a longer crop rotation, because in addition to grain crops, which are corn, soybean, wheat, and oats, we're also growing forage crops, which is alfalfa and orchard grass for the livestock. The organic legume system is a low input system. It is only using plants as a form of fertility. So it uses leguminous cover crops like clover and hairy vetch as a source of fertility. And this has never received any external inputs or fertilizer during its history. And the synthetic system, or the conventional system, follows the standard practices of the day. All the recommendations come from our university system. In 2008, we added genetically modified corn and soybeans into the system. We use synthetic herbicides, now that we've had genetically modified crops, we haven't needed to use insecticides, because there's insect tolerance and herbicide tolerance. And then in 2008, we added no-till. So in the conventional system, it is a continuous no-till, where we have not tilled the soil at all since 2008. But in the organic system, we till to plant small grains, we till to plant cover crops, but we have a method where we no-till corn and soybeans. So we call it a reduced tillage system. And my point on this slide is to just say that every time we take a lot of soil measurements, we look at almost every soil health measurement there is. And in 2019, we did a comprehensive analysis. We took over 100 soil health indicators. And every time we do this, we have a very consistent result. The manure system, the more diversified organic system, that we're using compost and manure back into the system, is as healthier. The soils are healthier. Followed by the legume system, which doesn't have as much compost fertility, which doesn't have as much carbon put back into the system, into the fields. And we also, the diversified, I didn't mention this, but we now have 2 conventional systems. One that does not have cover crops, So that's the non-diversified conventional system, and one that does have cover crops for what we call the diversified conventional system. And that one also has wheat added into the system. But either way, we don't really see tillage, or the lack of tillage or more intensive tillage playing a role in soil health. The health of the soil is much more driven by the organic amendments and inputs in our management practices, organic management practices, than they are by simply reducing tillage. And we did a study that looked at nutrients. It was not a real in-depth, it was a broad assessment of nutrients over a 12-year period from 2008 to 2020. And some of the key takeaways are that in our maize or corn system, we had higher protein levels in the organic, both the legume and manure system. We are finding, and seems to be consistent, higher protein levels in the conventional wheat, and we are seeing higher protein levels in the legume soybeans. And you'll see this on another slide, but some of the reasons we think that are attributed to these results are that in the corn or the maize, we have created the system in the organic system that have sufficient nitrogen during the corn phase. We have a hairy vetch and we apply the composted manure for the corn. The conventional wheat receives 60 pounds of ammonium nitrate, which is the recommendation from our local university. But the organic wheat gets no additional nitrogen fertilizer. However, we do not see a difference in yield. So the production or the yields of the wheat across all the systems are similar or equal. So let's just take a quick snapshot of, this is 2019, and first I'm looking at the soil. And like I said, the manure system or the more diversified system is almost everywhere we look has healthier soil than even the legume system. But I'm making the point here because we see we have an improved pH, we have higher total nitrogen stored in the soil, higher phosphorus, higher calcium, higher magnesium, higher sulfur. So we might expect that the crop that we're producing on these soils will also have higher phosphorus, higher calcium, higher magnesium. But this is wheat grown in those same fields in 2019, and we don't really see major differences. We do see what looks like almost a significant increase in iron in the manure, in the wheat grown in the manure system. We see a significant increase in magnesium, but probably because we're using additional synthetic nitrogen in the conventional system, we have higher protein and also have higher vitamin B6. And vitamin B6 has nitrogen as as a component, and so we tend to see that when we increase nitrogen application, we increase vitamin B. But we're also seeing that when we increase nitrogen, we reduce vitamin C. So there seems to be a trade-off. It doesn't just necessarily make it healthier to apply more synthetic nitrogen. But you also notice that the calories are higher in the conventional, significantly higher. And this is important because we want to measure nutrient density. And we consider nutrient density a measurement of the nutrient concentration divided by the amount of energy, because you're going to eat the energy you need to sustain your life. And the question is, are you getting enough of the nutrients when you eat that? It's also important to consider nutrients that are critical for human health. There's some nutrients that we really are never deficient in, so we shouldn't really consider it as part of the calculation. And this is just an example, but we've used one that's probably one of the more simple indexes. It's called the nutritional quality index. And it's basically taking a sample nutritional value, what we were getting from our crop, and comparing that to a reference daily value. And then we get the caloric intake, and we compare that. In this case, I'm using 2,000 kilocalories. 2,000 kilocalories is what is the recommended need for most women between the ages of 18 and 54. If we want to calibrate this to men, the caloric need for most men in that age range is 2,200 kilocalories. But either way, we would then calibrate the reference daily value to equal that. But when we do this calculation, we should get something somewhere around 1. And 1 would indicate that if you ate that crop, and you ate 2,000 calories of that crop, if it was at 1, you got exactly the amount of nutrient that was needed for that day. So here, I took those same results from wheat in 2019 and calculated several different indices. One is the mean NQI, the Nutritional Quality Index. The other one uses a smaller set of nutrients that I've highlighted in green because they're even more important, more valuable for human health than the other nutrients. But it also adds fiber, which is critical for human health. And then I used another one that was calorie for nutrient, very similar to the NQI, although if it's lower, it's better. Higher is worse, because it's basically saying you're getting more calories in your diet for the nutrient levels that you're eating. And so when we do this, if we were to ask the question, is organic wheat healthier than the conventional wheat, we actually can look and say we're not finding a statistical difference between the nutritional value or the nutrient density of the manure system or the organics over the conventional system. So this is a method we just started to apply. We're going to start to apply this to more crops that we're testing. We're going to start testing not wheat broadly. Well, maybe I should go to the next one. Not yet. Testing wheat and oats as well as vegetables, and do that not only and test multiple years and broadly across, maybe not even this United States, but across the world. And I want to show you quickly some results from our vegetable systems trial. Our vegetable systems trial is started in 2017, so it's much newer. But it's similarly designed, where we have a conventional and an organic, and then we have high tillage. In this case, we're using a black plastic mulch and intensive tillage. And we have reduced tillage, where we're using some of the similar methods, where some crops just get planted without any tillage. And so here I'm showing you results from winter squash, and these results span 3 years. So the other thing that will be important is to add multiple years of data to the data set. But what we're finding, which was really unexpected, was that we're starting to see differences in some of the major minerals. So calcium, magnesium, iron, and copper, vitamin B6, and protein were all higher over a 3-year period in the organically produced winter squash. And then it looks like reducing tillage is also playing a major role. So by reducing tillage, we increase phosphorus, potassium, calcium, and copper. And it's important to note that it's hard to know whether or not these results could be replicated broadly across multiple regions. But we're tracking the soil health at the same time, so we have the opportunity to look at changes that are occurring over time to these crops and how the soil and changes in the soil are related. So we also are looking at potatoes. So the variety of potatoes is Lehigh, and we're seeing some similar results. The organic potatoes were higher in potassium, magnesium, copper, vitamin B6, and protein. And the reduced tillage was higher with iron and vitamin C. And one major area of research for Rodale Institute is how can we reduce tillage in organic systems. So we aren't able to use herbicides, and successful organic farmers typically are using the high levels of tillage in order to control weeds. But we're seeing a benefit in reducing tillage to the nutritional quality of food. So we'd like to not only reduce tillage in organic systems because we think it'll be more profitable for farmers because it'll be lower labor, but because we think it'll be healthier for the consumers who eat organic produce. And let me briefly touch on, how a deeper dive that we're taking into this compound called ergothioneine. Thionine is an amino acid. It's only produced by fungi or fungi-like bacteria. So we know that it's high in mushrooms, but we're obtaining ergothioneine from the soil. We know that a lot of foods have it. It can be high in certain foods like oats and black beans. And so we must be obtaining ergothioneine from our diet. But in the medical research, they're starting to see that it's an important antioxidant. It's anti-inflammatory. It looks like it's mitigating cardiovascular disease as well as neurodegenerative diseases like Parkinson's and Alzheimer's. So we started it also looks like soil disturbance or tillage is playing a role. This is not a Rodale study. This is a study from Penn State where they have long-term tillage, and we see lower levels of ergothioneine in crops where we have intensive tillage like moldboard plow. So this tells us we probably need to start reducing the tillage and are starting to ask us the question, well, what is causing this phenomenon? What is causing this effect? So working with collaborators at the USDA ARS, who have a specific lab in mycorrhizal fungi, we've actually been able to demonstrate that mycorrhizal fungi, or at least specific species of mycorrhizal fungi, play a role in taking up ergothioneine into crops. And I'm showing you wheat as well as oats, major crops, that this one specific species of mycorrhizal fungi increased levels compared to what we're calling a mock or sterile that has no mycorrhizal fungi. So this was the first time that we demonstrated that mycorrhizal fungi play a role in ergothioneine levels. And it makes sense then that increased tillage, which we know disrupts mycorrhizae in the soil, could be disrupting ergothioneine levels. And I'll go through this quickly, but what we tend to see is that in over 2 years of testing oats and 1 year of testing wheat, we tend to see that tillage is playing a major role in increasing levels of ergothioneine in our crops in the farming systems trial. So we've started a collaboration, a 5-year collaboration with multiple universities and farms across the United States to take a more in-depth look into not just ergothioneine, but nutritional quality levels in both corn and wheat. And I'll just show this very quickly. This is from our vegetable systems trial, 2-year period. We knew that black bean is very high in ergothioneine, and you see that in both black bean and green bean had higher levels of protein during that 2-year period. Also had higher levels of ergothioneine during that period. So in the vegetable systems trial, even the reduced tillage system, because we're growing potatoes, requires some soil disturbance in order to plant and dig out the potatoes. And this is my last slide, but I just want to show you maybe where we're going. One, we want to publish these results so everyone can see them and get out to the world. We're going to do a more in-depth nutrient analysis. This means testing more nutrients. We've just sent our wheat off to be tested for over 100 different compounds, bioactive compounds that are in wheat that look like they're sensitive to management. And then I'm showing this last graph, which is the microbial basis, explore the microbial basis of phytonutrient concentrations. So we've used Streptomyces, which is a known ergothioneine biosynthesizer. We've identified the genes that synthesize Streptomyces, and they can have either one gene or 3 genes, so there's different levels of biosynthesis. We've inoculated with our collaborators at the University of Delaware, inoculated plants in the roots with the Streptomyces, and over time, and using spectroscopy, we've actually been able to track live or living Streptomyces that are moving from the roots up into the plant. And we'll start to ask the question how this relates into improving phytonutrients as well as ergothioneine concentrations in plants. So I thank you for inviting me. Here's my information, so please contact me if you have questions. And if there's time, I'm happy to take any questions.
Okay, lovely. Thank you, Mr. Smith. I don't know if we will have any questions, but probably not. But thank you very much. Very interesting.